Your mic's not working.
Okay, people, please find a seat so we can get started. Okay, so this evening we're going to start with 2 reports and then have a few technical topics. The first report will be mine as the IAB Chair, and then we will hear from the RFC Series Editor. The first bit of news from the IAB is that the NomCom cycle is completed, and so we have some outgoing folks to thank and some incoming folks to thank, and the continuing folks are going to continue to as well. But what I'd like is the 3 outgoing people to come up to the stage. Joel, Elliot, and Zing, please. So we have a plaque for each of these for their time on the IAB, and then a couple gifts from the IAB. So Elliot's first. Thank you. Okay. Zing. Thank you so much. So we'll never get broken. And these are so much.
Okay. Thank you.
Right. Thank you. And Joel. Thank you.
Thank you.
Okay, thank you. Thanks so much for your years of service. Yesterday, the IAB in the meeting held elections. Our chair position is elected each year, and I'm pleased to announce that Andrew Sullivan was elected the new IAB Chair and will be taking that position for the Open Mic this evening. Andrew, come on up. Many people don't know, because it's rarely used, the IAB Chair has a gavel. And so at this point, I will be passing the IAB Chair gavel on to Andrew. Wait a minute. So here's your gavel.
First I'll take that gavel. Oh, you want the? All right. Are you going to hit me with it?
This would be more appropriate, wouldn't it?
Too late. That's right. Of course.
Okay.
All right. Thank you.
Okay, what's going on?
So many of you may know that Russ has a fondness for ice cream, and so I thought that this was an opportunity for me to say, first of all, thank you very much for your service as the chair of the IAB. Russ is not going away, by the way. He is, of course, returning to the IAB, and we're very happy about that because I have lots and lots of work for him to do. But before I do that, I want to make sure that he enjoys his ice cream as a token of our thanks. So thank you very much. Where do you want us to leave that?
Yeah.
I'll leave it.
Okay. So we've had a really busy time since the meeting in Honolulu. This is a list of the things that the IAB has gotten done, and probably the most exciting one is the top one, where the IAB made a statement just as the Honolulu meeting was ending that we believe we should transition so that the internet is encrypted by default. And you can find that statement at the link behind the little here thing. We also made some statements about the Net Mundial initiative, and we published an RFC on smart objects in terms of a workshop we held. And we also published an RFC about architectural considerations, and that will be the foundation of the technical topic that's going to be discussed later. We also provided a statement about Unicode 7.0.0. There's some issues that are being discussed this week in the Lucid BOF, and later Andrew will be up to do some technical stuff and talk about how that is challenging some work that needs to be done in the IETF. And in the ICANN community, the root servers, the root server system advisory committee has gone through a process where they were restructuring themselves. It took them like 1.5 years to get that done. And at the end of that, we concluded that we want to continue a liaison relationship with that group. So we made a statement signed both by the RSOC chairs and the IAB that that's the case. Document status, I won't go through each one of these. You can see them on the slide, but we're continuing to work on these. And one of them, the IANA Principles document, is in Auth 48, so that ought to probably pop out sometime this week. And you can see the kinds of topics we're continuing to work on. There were no appeals to the IAB. You could hear about that on Wednesday. So we're working on appointment to the Internet Society Board of Trustees. There's information here about the process that's going on. The IAB has asked for input on the candidates that they have, and they want that actually this week. So if you haven't sent it already, please do so. We made 2 recent appointments. Benson to the IOC, and he will take that seat on Wednesday, and Paul to the ICANN Technical Liaison Group. I want to talk about 2 workshops, one that we had in January, and there will be a little report out about that as well tonight, and one that's coming up in June. So if you're interested in the Coordinated Attack Response workshop, the information is available at the URL on the slide. The IAB has structured its work into programs, and I'm just putting this up to let you know what they are and let you know that we're merging 2 of them. The ITUT Coordination Program and the Liaison Oversight Program are being merged, and so that will take effect this week. And so that's the end of my report. Heather, would you come on up? I think I get to eat ice cream.
I think you do get to eat ice cream. Yes, I get to give a report, you get to eat ice cream. The fairness of life. But my report is now going to be even faster. Okay, so I'll keep stuff pretty short and sweet. Highlights of what's going on in the RFC editor. This year, the RFC Production Center contract goes out to bid. That's just how the contract cycle works. I expect the revised statement of work, which includes an updated service level agreement, to go out for community comment within the next week or two. So keep an eye out for that and offer your input. I would really appreciate feedback. Once we've gone through the comment period, I'll accept, any changes, revise it as needed, send it to the IAOC so that we can actually start the bidding process this summer. The idea is to have actual contracts to be awarded by the September-October timeframe, and then if a transition is necessary, we have a few months to sort that out. Last IETF meeting, we had an experiment run on offering a writing lab. Authors could sign up to work one-on-one with an editor on particular drafts. This was targeted towards people who found English a rather challenging language to write in, so I thought about signing up myself. Didn't. And 10 people did actually sign up, and the feedback was that it was very positive for the participants. They really got a lot out of it. It was also a pretty significant workload on the production center staff because they had, usually coming into an IETF meeting, we get a surge of documents for publication, and trying to deal with that typical surge of documents as well as reviewing these drafts on top of that and preparing for one-on-one sessions was a lot of work. So we're contemplating if and how to support that going forward. So while we're thinking about that and if and how it can fit into the general services that the RPC might offer, I'm also considering creating a mailing list that I would moderate for people who just want to ask language questions about their drafts. Hopefully members of the community would volunteer to help me out with that. If you've got feedback on that, drop a note to RFC Interest because I'd like to know if the community thinks that's a good idea. The RPC will continue. They have a sort of a tips and tricks document. People often come by the desk and say, well, what's the most common issue that you find in drafts? What language problems are there to be found? So they've written this up, and we keep it up to date. I believe there's a copy on the Edu Team Wiki as well as on the RFC Editor website. If you want to go straight to it, there's a link at the bottom of the slide. How many people have heard that I'm working on the format for RFCs? Great. I just, I just like to check. So most of the drafts involved in setting the requirements for this are now at a point of what I call stable. Stable doesn't mean they're done. Stable means that they're now braced for impact when reality hits them, and we can adjust them accordingly. So they're not going to be published, but they will form the requirements for the tools and the service going forward. If you want to see the list of what the current drafts are, there's an RFC format FAQ off the RFC Editor website, and that's out there for anyone to see. We had a comment period for the statements of work that will go along with the tools necessary. That comment period is closed, but if you've still got things you want to add, feel free, drop a note to either RFC Interest or to the tools team. These will go out when the last of the drafts have reached stable, so hopefully not too much longer. There are other things underway besides format work. I know some people find that hard to believe at times, given just how big that project is, but there are things happening. Digital object identifiers. This is of particular interest to many members of the academic community. That's actually now in the programming phase. So we expect to see DOIs assigned to all past and present RFCs, as well as all RFCs as they are published going forward by the end of April. The RFC Editor website, a really, really old-looking website. That is also now in programming phase to be brought up to date and actually look like something that was made in this decade. We're working on the scripts behind the scene. That's going to take probably, I think it's supposed to run through September or so. in getting that cleaned up and looking like a modern thing. Google Scholar. I don't know how many of you knew that we were working with Google to get RFCs properly indexed in Google Scholar. That's a project that's still underway. We've completed everything on our side in terms of the metadata tags that they wanted and other little bits like that. And now we're just waiting for the actual indexing to happen. They've got a lot of things that they index, so this takes some time. And that's it. If anyone wants to know what's going on, wants to start a conversation about RFCs, RFC format, any of the projects, or if you want to see what's happening with the RFC Oversight Committee, there are your links. He didn't open the ice cream. And we'll go on to smart objects, I think.
Alrighty, so as Russ noted earlier, our technical topic for this evening is smart objects. First, Dave Thaler is going to kind of give an overview and highlight some of the architectural considerations that came out of the IAB work, and then Hannes is going to talk about some of the security and privacy considerations around smart objects. And then we'll open the floor for about 15 minutes of Q&A.
Okay, so a few years ago, the IAB observed that there were a number of smart objects being deployed, developed, that did not have IP in them. And so we said, what should we do about this? So we organized this workshop a couple years ago that resulted in the RFC that's on the screen there. That RFC made a couple of recommendations. One of those recommendations was specifically for the IAB. It was that the IAB develop architectural guidelines about how to use existing protocols. Okay? And it also made some recommendations for the IETF to address. There was also this belief in the industry that IP just was too big to fit on these smart objects. And so that was part of the workshop in the RFC as well. And so we, the IAB, wanted a document that would describe when and why it was appropriate to put IP into smart objects. And so this RFC that just came out this last week is the result of that, a couple years of effort. And thank you to many of you in the IETF that sent us great comments and helped us to improve that, because the audience of that document is not you all per se, it's the smart object engineers. Right? This talk is tailored to you, and I'm going to talk about a couple of things that are in the document and kind of what's left for us to think about. So while the IAB was working on their part of the recommendations from the workshop, right, the IETF and other organizations were also working. There's been, I don't know, at least 7 or so different working groups in the IETF that have been chartered, made great progress, and so forth. The IRTF just met had a proposed research group, right? That's kind of the IRTF equivalent of a BOF that met this last weekend. The LWIG working group has an RFC that's the one that's on the slide there that has terminology for constrained nodes. And this talks about smart objects that go all the way down to having much less than, say, 10K memory and 100K code. Meanwhile, outside the IETF, various other organizations were busy. Right? We had things like the Zigbee Alliance that created the Zigbee IP profile that then adopted IETF technologies. We had the Bluetooth SIG and IETF working closely together on IPv6 over Bluetooth Smart, or BTLE. And you had a plethora of IP-based alliances that were either formed or expanded, and a bunch of them are listed there in alphabetical order. And meanwhile, the hackers themselves were also working overtime. So we've had all kinds of different headlines that you may have seen over the past 2 years or so. Right? We've had attacks against televisions. We've had hacks against thermostats. We've had hacks against light bulbs. We've had hacks against front door locks and power outlets, even certain toilets. Right? It says, hacking a smart toilet is either a neat trick or a mean prank. Right. That same article then goes on to talk about taking over the hubs that may control all of the home automation. And the hackers did some very creepy things with a toy bunny. So what's so special about a smart object anyway? Well, there's at least 4 different things. There's not one thing that's a smart object. Or when we say Internet of Things, it means many different things. There's at least 4 different criteria that you might say apply to different types of smart objects. Right? Maybe it's very constrained in some way. It doesn't have very much memory or bandwidth or what have you. Maybe it interacts directly with the physical world even when a human isn't present, and so in some sense it may be more dangerous in that respect. It might be physically accessible by untrusted parties and therefore very hard to secure. Or it might be physically inaccessible by trusted parties and be very hard to service. So a particular smart object may have any one of those criteria and maybe more. So when we talk about smart objects, right, there's a big space with lots of different things going on. So when we in the IAB looked at smart object architecture, we looked at sort of three categories of architecture, right? Starting from the bottom, there's decisions that our smart object engineers make around hardware, right? Which type of radio is in there? What's the radio technology? Is it on battery or is it powered? Things like that, okay? On top of that, they make decisions based on software stack, right? Is it this software? Which protocols are in there? Which protocols are implemented and so forth? And on top of that, you have information or data models that say, what's the schemas for these different things? Like, what is a thermostat? What does it expose? That type of thing. Historically, the IETF typically focuses only on the middle layer, okay? Now, of course, in the IAB, we think about things wider than just the IETF. We think about the things that the IETF and its relationship to many other organizations. So that's kind of our job, is to look at the big picture, point out gaps, and facilitate relationships between organizations. When the smart objects get connected to the internet, things get a little bit more complex, okay, which is you have to deal with the internet protocols. You may have to deal with corresponding attacks against those protocols. And there may be additional privacy issues, for example, multiple jurisdictions, right? If you have a smart object that's not connected to anything else, maybe the only jurisdiction you care about is the one it's physically present in, right? But once that thing is communicating across the internet, the communication itself may span multiple jurisdictions, and therefore may have additional legal issues to deal with. So this is kind of the one-slide version of what the IAB was asked to do in that workshop, which is, to summarize, there's still trade-offs of putting IP in smart objects, right? You see the stack on the left and the stack on the right. If you do put IP into a smart object, you have the left stack, and this means you have to devote, you the smart object engineer, have to devote some resources to TCP/IP, where that same resources, silicon or what have you, could have been devoted to something else that device might be able to do. And you have to worry about potentially securing IP from outside the local network. If, on the other hand, you don't put IP in there, okay, then you usually need some application layer gateway in order to actually accomplish the rest of your scenario. And that can be a deployment burden. Second example is you might end up reinventing things the IETF already did, congestion control, security, reliability, and so forth. And so you see the app box on the right is a little bit taller than the app box on the left because it includes part of the things that are classically inside TCP/IP. And finally, and perhaps often the most important, is you can't leverage the large ecosystem of IP-based knowledge, tools, personnel, training, operational experience, and so forth. The economies of scale that you get from using IP. So this is the inherent trade-off that they have to make, is to say which one of these things is more dominant in their case. As we went through this exercise, we identified 4 common communication patterns, and these are the same communication patterns that show up in some other working groups and things, that we evaluated what's the architectural impact of. So I'll walk through each of these. The first one is the device-to-device pattern. Okay? That means you have a smart object that's either talking to another smart object, or talking to another device that's not a smart object, but there's a local network in the middle where that could be IP or it could be non-IP, right? That could be Bluetooth or Zigbee or what have you in the middle. And the trust and security and such things are, as deployed today, typically based on direct relationships between those two. Sometimes the term pairing is used. Now, if you look at what's actually sold on the market today, most of those things today don't use IP. Okay? Instead, they directly, so it's the picture on the right of the previous slide. Bluetooth, Zigbee, Z-Wave, and so on. Each of those have a forum that takes care of standardizing how to do application or device-specific schemas over that particular layer 2 protocol. And so as a result, today when we look around at what the current state of affairs is, we have many different organizations that are trying to define data models for different types of smart objects. So how many models of a light bulb or a thermostat are there? There's a bunch of them across the industry right now. That's just the current state of things. There's no common information model. So here's an example of a bunch of devices that fit into that category. Okay. Second pattern is the device-to-cloud pattern, right? So in this case, the smart object connects to the existing network and connects back to a cloud service that's typically run by the same vendor as sells the smart object. Okay. The benefit, of course, of this, the reason why they do it, is so that you can access that device or data from anywhere, right? You just talk to the cloud service and you get access to it. But the smart object is constrained in its choice of layer 2 media because it can only depend on what's already ubiquitously deployed in the environments it is being sold for. So in many cases, such as in the consumer market, this means it's Wi-Fi. Okay? Now, even with Wi-Fi, the question is, how do you get it on the Wi-Fi network to begin with, right? You got to get the keys into the thing to get it on the Wi-Fi network. Well, the second problem is there's no ubiquitous standard for configuring the smart objects of those keys. So everybody has their own mechanisms. So often from the same vendor, often on a per vendor basis. And so this whole thing together tends to mean that in this picture today, you see lots of silos, right? This vendor's red line, a different vendor's red line, and so on. And so what happens here, one of the concerns is that the device object, if that cloud provider ever goes away, goes out of business, or sometimes even changes hosting provider, that smart object can become unusable if it can no longer connect back to the cloud service it's expecting. Okay? And so we point out in the document that's tailored to smart object engineers that there's ways to mitigate that by saying using standard protocols, hopefully IP-based, and or using open source. So here's some examples of devices on the market today that fit into this category. And the top left one, Little Printer, is interesting because this cloud service is actually shutting down this particular month. And so it's an example of that case at the bottom of the last slide. They've chosen to say they're going to open source their implementation to allow somebody else to do cloud services. So they've already had to go through this. The third pattern is one that kind of takes the other two and puts them together. So the red line there is saying the smart object talks to some application layer gateway. It does this so that that application layer gateway can then facilitate communication off to the cloud, such as in the device to cloud model, or to a different local area network, which is the bottom dashed line. So this is commonly used whenever there's L2 media that's not ubiquitously deployed, say when the red line is going across 802.15.4, or say in an enterprise environment where you need some custom authentication mechanism that's there, or when you want interoperability with legacy non-IP devices, right, between two different local networks there at the bottom. Okay, so here, often the smart object and the ALG are from the same vendor. And of course, one of the common models is where the ALG is just an app inside of a smartphone. Now, it's worth pointing out, because we like to look for IPv6 in places, that having an ALG, actually, there's problems with ALGs, but one of the benefits here is that this does allow IPv6 only devices to access things that aren't IPv6 capable, whether they're non-IP or they're legacy v4 only cloud services or legacy IPv4 only devices. So one of the main points we tried to make in the document was those ALGs, right, we want them to be more generic and not vendor specific, to work in more classes of devices. Okay. So our point was that more cheaper and reliable ones are going to be more likely if the devices use standard protocols that don't require an ALG. Okay? Well, that only goes so far because one of the problems that we have today goes back to the choice of data models and schemas, right? Even if the protocols are standard, right, if the schemas aren't the same, you still need an ALG to map the schema. Okay? So we can't, in our IETF at least right now, we can't completely solve the problem, but we can give advice and point out what the gap is and facilitate relationships. So here's an example of some things on the market that are sold as the ALGs in this picture. And here's an example of some things that are sold as smart objects that use an app on a smartphone as the ALG. Okay, so the point is that all of these models are actually widely used in various markets today. And here we pick most of our examples from consumer markets, but the same thing happens in other cases. The fourth model is a little bit different, in that it goes together with one of the previous ones, typically the cloud-to-device one. And this is where you have different silos from different vendors, but you have scenarios where you need information from different silos together to accomplish some particular task. And so, because you have proprietary schemas that go back to there, this is where you have two cloud services that either federate or have APIs between them to allow things to work together. So, for example, RESTful cloud APIs and so forth. So standard protocols, again, help, but aren't sufficient because you need to have standardized information models, or at least common information models in between two vendors. They're speaking the same schemas, if you will. So here's an example today where you have smart things on the left and you have a drop cam on the right, and you can have a smart things application running on a smartphone that can access the drop cam specifically because their two cloud services provide communication in between each other. So to summarize the observations that we made about the current situation regarding standardization. First issue is that information and data models for various types of smart objects, that there's not a single one that's out there. There's a plethora of them being defined right now. However, today this is mostly outside the scope of the IETF. About the only ones the IETF focuses on are data models specifically for connectivity, like what's the model for a router or a switch or a bridge or IP configuration in a device, right? But not for things like thermostats and light bulbs and so forth. There's many other forums in this space with the usual discussions around how you deal with that. But that's one of the things we as the IETF look at and point out and facilitate. Second example that I pointed out was how do you get an application onto an L2 network, such as a Wi-Fi network? How do you get a smart object onto that? Well, today, if you look around, there's not a single ubiquitous standard, right? There are some standards, like WPS, for example, that aren't ubiquitously accepted by all types of devices and operating systems and things. So that's about the closest we come to things that are like standards. And so today, you have various proprietary solutions. One common one is just where they put a web server into the smart object, and so you connect to that thing as an AP, you configure it with a web page, it drops off, it connects to your regular Wi-Fi network. So that doesn't require a standard protocol, it just requires putting a web server into the little smart object, right? And so there's still some desire for having a common mechanism rather than having every configuration of every device be custom. But it's not clear which organization is the best one where it belongs. Is it the Alliance for the L2 technology? Is it the standards organization for the L2 technology? Does the IETF have a role? We're not sure exactly, but certainly as an IAB looking at the big architecture, it's something that we're looking at. And of course, standardization for most of these, right, it's just seen as being too slow. So even if something does get standards, things are going to be out there in the meantime. So as the IAB, we're often seen as people who look out for the end-to-end model. And so what impacts does this have on the end-to-end model? Well, there's two IAB RFCs that are worth calling out here. The first one is 1958, which is the architectural or design principles. It says, among other things, the goal is intelligence is end-to-end rather than hidden in the network. Okay. But if we go back to the RFC that I quoted from the LWIG working group, it talks about that the tiniest of devices don't have enough to actually serve internet connectivity on their own. So they need some gateway type thing. So what does that mean for the end-to-end model? Second example, again an IETF, an IAB RFC. Right, 3724 is a statement specifically on end-to-end considerations. And it talks about requiring modification in the network is typically more difficult than modifying end nodes. Okay? That statement is no longer necessarily true, right? Well, it can, for example, it can be really expensive, as Hannes will tell us in a second here, to put a secure software update mechanism in a smart object. And it might have a very long lifetime. And so as a result, people put modification in the network because they can't change the end devices if they have a long lifespan. So what does this mean for the end-to-end model? These are things that are our job to think about. We're thinking about them. Your input is welcome. The last slide before I hand off to Hannes is that, when we talk about cost, right, often we have to think about the total cost of ownership, which is the sum of at least three things, right? Hardware, energy cost, development cost, and maybe some other things. And this notion of, gosh, it's too expensive to put something in is focusing just on the hardware cost, right? And sometimes people say, or, organizations that do smart objects try to compete on other things, like, you buy our object and we will save you money on your power bill. That's smart power management. Or the deployability, right? Management stuff may make the total cost of ownership go down because we do a good job of managing our objects and things. And so this notion of, gosh, it's more expensive to put that into there doesn't have the whole picture in it, okay? Of course, in many enterprises, right, these things may come out of different budget lines, and so it can actually be difficult to get across this concept of total ownership, or at least get the budgeting to work out. Okay, so all of these factors have to be taken into account. And so with this, I'll hand off to Hannes for the security part of the discussion.
Thank you, Dave. So there are different methodologies for actually designing a secure IoT system. And I have described 4 of them here, and we'll go into the details of 2 of them only. The first one is one that you are probably very much familiar with, because it's a methodology we apply often when writing security consideration sections, and apply the work that the IAB has done on RSE 3552 for that matter. And the last item, the following design patterns, is something that Dave has just talked about, and obviously in taking or learning from those patterns, people also apply the security mechanisms used in those. The IETF, however, has a lot to say also in providing guidance and recommendations in the security environment that are also applicable to the IoT context. And furthermore, it's very common to actually look at attacks to learn from mistakes that others did, and I would like to focus on those two. But before I do that, I would like to highlight that the whole process of developing security solutions is often fairly complicated because there are many different communities involved. And if you look at that picture on the left-hand side, you see the cryptographic community designing principles or primitives like encryption algorithms, hash functions, and so on. Standards organization developing protocols and architectures. Implementers actually turning those specifications into code. And then finally, the community who does the deployment. And of course, each of those communities have to fight with their own different unique problems. So implementations, as you know, often deal with buffer overflow vulnerabilities, require all sorts of extensive testing and so on, secure coding practices, etc. So understanding this whole sort of distributed nature of the development process is obviously crucial to deal with some of the security problems on the internet, and also in the same applies to the IoT context. As said, the IETF has a lot to contribute in that environment, so I picked a couple of those examples which I think are particularly relevant. There's RSE 4107 focuses on key management, and it discusses the relationship between manual and automatic key management. And by now we all know that solutions should focus on automatic key management. I will show you on why this is still relevant in context of attacks that we see today. A recent publication, RSE 7258, talks about pervasive monitoring and recommends to use encryption, and Russ mentioned the statement early in the plenary. An ongoing effort is documenting the crypto agility and to allow specifications and implementations to actually migrate from one cryptographic algorithm to another one in case there are advances or there are problems with one of those algorithms. And specifically considering the long lifetime of IoT products, we're talking about 10, sometimes even 20 years. That's obviously an aspect to think about. There are randomness requirements and key length recommendations that I'm going to talk about in the next two slides. But it's also worth pointing out that there are two working groups dealing with protocol-specific recommendations that are worthwhile following and looking into, specifically focusing on the use of transport layer security. You can follow up the links if you don't know the book. So RSE 4086 provides some recommendation requirements, and they are very important in the context of security protocols because those require randomness in various places, such as nonces for key transport, for key generation, asymmetric key generation, and also for certain signature schemes. So it's a crucial aspect. And in the PC world, that's quite easy to, or on server side, it's also very easy to accomplish. However, in the embedded space and an IoT space, that turns out to be complicated because many of the sources of randomness are actually not available. And I list a few examples here. For example, the timing, clock timings, the input events like mouse movements, keyboard movements, keyboard clicks, disk access timings, IRQ timings, and so on, are not available. So what you then find, as these two papers, the linked papers, indicate, that in the wild you actually see many systems basically having no sources of randomness, generating the same keys over and over again, which is obviously fatal for security. Key length recommendation is another important, or the key length is another important consideration. As pointed out by Dave, in many of the IoT devices have constraints in terms of CPU, so processing speed, memory, and so on. So the temptation is huge to actually reduce the key size to increase performance. But you can, if you go beyond below a certain threshold, obviously the security is worth nothing anymore. The Utah TLS BCP recommends today 112-bit symmetric keys to be used as a standard. And if you look at many of the publications and products, you will see that those do not meet those recommended key sizes. There are other publications who recommend slightly lower key sizes depending on the usage and the lifetime of the key, but it's worthwhile to keep that in mind. Also, for the use of asymmetric algorithms, In the IETF, for many of the specifications, the elliptic curve cryptography is recommended because of the shorter key size. Jumping over to attacks, I looked at many different cases and tried to categorize them and to see what attacks we see today, even though some of the deployments are still in a very young and early stage. So I have 5 different categories that I think are worthwhile to highlight, and there are some lessons to learn from. Also, what I like to point out is that there's obviously, with some of the patterns, communication patterns, you have to consider the server side as well, the server side infrastructure. If you don't secure the server side, obviously it makes no sense to just secure the client side when the IoT devices upload everything to the cloud. And that's also what the OWASP security project recommends in their IoT guidelines. So start with the first one. Beginning of last year, Bruce Schneier had an interesting article where he points out that many of the IoT devices have no convenient software update mechanism, and that's indeed true. So in this specific case, a case from the Chaos Communication Congress published last year, end of last year, it was pointed out that a software update mechanism using TR69, an implementation found in many routers, but also in home routers, but also in many Internet of Things appliances who use the same mechanism, had a bug, and that's obviously not uncommon. So it's good to have the software update mechanism, but that specific one had a bug, buffer overflow, and that bug the software was shipped in 2002. The bug was fixed in 2005. But unfortunately, to the long value chain between sort of the company producing that server and silicon vendors and ISPs and etc., these boxes are still vulnerable today. So it's not only important to provide the software update mechanism, but also then to find out on how to distribute the software updates itself. So, and that raised the discussion on whether some of these IoT devices should actually have a sort of a time to live, referring back to the little printer that Dave mentioned earlier. So should these devices die after a certain time, or when the vendor decides that it doesn't support it anymore? Also fairly common is a missing key management. And here's an example from a light bulb again. In this case, in many of those lighting scenarios, you have smartphone connecting to being used to control these lights, and they connect to those using wireless LAN. But then the lights themselves use IEEE 802.15.4, a low power radio technology, in a mesh multi-hop network. And of course, you need a key management solution there to secure the messages. And some of the vendors take shortcuts. And in this specific case, the shortcut was to use the same AES key in all of those products, which of course simplifies the key management tremendously. Up to the point when some researchers came along, extracted the firmware image and used IDA Pro to disassemble the code and found the key. And then obviously that, lacking a firmware update mechanism obviously didn't help either. You may think that these are mistakes only made by small startups who don't have the resources. Unfortunately, that's not true. As the recent example from BMW with their connected drive shows, because they had the same problem among other problems. Another LED light bulb example is this one, that illustrates a missing access control. So in this case, it was reported that hackers had used light bulbs and the missing configuration setting there to turn on and off the lights, which is pretty annoying. And they used a nice program called ZMap to scan the whole internet to actually find them first, which is a very efficient version of Nmap. Doesn't even require an hour to search the whole internet, IPv4 internet. And so you would wonder, like, who would care about light bulbs? Who would want to switch on and off my light bulbs in my house? And that's a fair question. However, it turns out that other products have the very same vulnerabilities, like cameras, surveillance cameras, baby cameras, gas stations, very much the same pattern. And there you can very easily see the problems. And even websites that actually list you can conveniently browse through surveillance cameras and other cameras found on the internet to see what people are doing. And if you switch to industrial control systems, you very quickly see the potential of harm that can be done. And I've included an example on where exactly the same problem happened. In a publication called Green Lights Forever, some researchers looked at traffic control systems, and you see an architecture picture on the right. It illustrates on how these on the roads, how these systems are interconnected wirelessly in the different components. And it turns out even also for these systems that the wireless communication is not secured using encryption. There are default passwords used. Some of them are even hardwired, so you can't even change the default passwords. And what I like most with this one, in another publication, researchers expanded that attack and used drones. So they wrote in that paper, even tested the attack launched from a drone flying at over 650 feet, and it worked. And that's may give you some nice advantages as you go through the city. An attack, some of the attacks, IoT devices enable another class of attacks, which I have previously not been exposed to too much before I started working at ARM. And those are physical attacks. And for those, you often need some special hardware, which I show on the right-hand side. And you can do power analysis, glitching attacks, used to either bypass access control or extract keys in a fairly convenient way, even though the crypto techniques are perfectly secure by itself. It's the implementation that leaks some information. And what is interesting in this environment is that the tools get cheaper and cheaper, and there are lots of tutorials on how to use them. So it's more accessible to a broader audience. And I believe we will see more and more of those in the future. So the upper one called JTAGulator is a tool to connect to different pins on a printed circuit board, and the platform then searches on and finds out what communication protocol is used, and potentially then you can connect to those different components, to different modules on that board. Very nice tool. The lower one is called Chip Whisperer. It's a platform for doing side channel analysis and side channel attacks and glitching attacks. Also available for a very good price. We're talking about $500 here. As a remark from those attacks, I think it's fair to say that many of the Internet of Things security we see today is very much like the PC security 20 years ago. Even though many of the attacks today look more like the attacks of script kiddies, but if you look outside the consumer space into the industrial environment, you already see the potential or the direction where this is heading. And one example here was an attack last year at a German steel factory where the attackers managed to change the process and damage the steel factory. And in another attack in Poland, a pipeline was blown up, and it was done in such a way that the administrators of that system, who continuously monitor it, only learned about the attack 40 minutes after the attack has actually happened, after the pipeline blew up. So it's those are more sophisticated, and you obviously need to understand the processes of the factory, so different incentives here. The risk analysis for many of those IoT devices is also more complicated, because they are not only the direct risks that are probably come to mind to most people, but there are also indirect ones, like we have seen with DDoS attacks years ago against Comcast, or using printers, where reflection attacks were used in a massive DDoS attacks. Moving away from security, I would like to also touch briefly on privacy, since we got a lot of comments on the privacy side. The IAB publication RSE 6973 provides good generic guidance, and many of it is also applicable to engineering efforts in the IETF for these type of protocols. So it's definitely worthwhile to look at those. But IoT poses a couple of other additional challenges, and I list two of them here. Like the quality of consent. Many of the devices don't have a user interface, so it's very difficult to ask user for consent in a real-time fashion or in a meaningful fashion. There's also desire of companies to use big data analysis and to collect lots of data from different devices and then correlate those to find new interesting insight. And doing that obviously raises privacy concerns for the end users. And there's a publication that we reference that was timely in that sense from one of the European institutions that specifically focuses on those aspects, deployment-related aspects. To summarize, so one of the observations that we made from the workshops and also from writing the report, that we believe that using IETF and Internet protocols is for Internet of Things is definitely doable and is important and saves a lot of problems. The recommendations that we provide are solid and can be used. So those include using state-of-the-art key lengths, using well-analyzed security protocol, use encryption to deal with pervasive monitoring, and also to support automatic key management with all the considerations that go along with it. However, there are some IoT-specific recommendations that I would like to point out, that crypto agility is something that's a hard decision and for designers, and they have to deeply think about it, specifically since many of the algorithms in IoT devices for performance reasons are actually in hardware. So switching from one algorithm to another one is actually not that easy. To also integrate a software update mechanism and leave enough headroom for these updates. Include a random number, hardware-based random number generator in the devices. And many of the chips that you find out today actually don't have such a random number generator. When you do the threat analysis, also think about physical attacks, because as I said, they would be more common. And also use modern operating system techniques on those devices, since many of these embedded systems have a very simplistic concept where a single bug in the whole software can ruin the entire security. There's no separation of processes and so on. Thank you.
Thank you, Hannes and Dave. So now it's time for questions and answers. Just to let people know, we are actually using some smart objects for queue management, and we're using light bulbs, of course. They will start out green when you first start asking your question. They will fade to yellow as your time is running out, and then you will get a flash of red, which means it's time to stop talking, okay? So if people can be concise, and they'll let everybody have an opportunity to ask their questions.
Is that enforced with some kind of laser gun? Or?
I can't, we're not hearing you in the microphone, Christian.
Pardon me? Oh, this one doesn't work?
Yeah, I don't think that it's on. It's already been hacked. Let's go ahead and start over here while you're, yeah.
Thank you. Mike Jones, Microsoft. I'm curious, Hannes, Dave, others, where are the IETF's points of leverage in this conversation? I mean, commercial reality is that people will get things in the marketplace and sell them if they appear to work, if they are commercially viable at the moment, and asking people to do things like put an expiration date on your product is just probably not commercially viable. That being said, we have a lot of experience. What conversations are we and should we be having?
Okay. Yeah, that's a very good question, Mike. So you see different folks in the community who work in that space providing not only sort of their time to develop specifications, but also writing code, providing open source software. So I hope that, and there are all sorts of publications that say we will have 50 billion of those devices or even more in a couple of years, that the companies who, most likely also many small companies, who would then focus their efforts on providing some competitive technology rather than spending all their time designing new security mechanisms and internet protocols. So they would just reuse the existing stuff, not only specifications, but also the code that they have. And so hopefully by doing that, they will avoid many of the pitfalls. And so they actually spend their time on the things they are good at.
Okay. I'll just add that the leverage is that they make decisions based on what's cheapest and most financially profitable for them. So to the extent that we can do the design work for them so they don't have to repeat that, and the fact that we can have a large ecosystem of compatible personnel, experience, tools, and so on, then that becomes economically better for them. And so I think that's the indirect tool that we have is rough consensus and running code.
Okay, thanks, Mike. Okay, let's move to the back right microphone since Christian was up here at the dud one. Yeah. That one's not working either? Holy moly, that one wasn't working either. I don't think that one's working either. Do we want to grab one?
Make sure it's on too. No. There we go.
This one or not? Hannes, at some point you said in your presentation, you talked about like maybe introducing some kind of lifetime for devices and shelf life. So I understand like where this idea would come from, but we have other kind of responsibilities too. I mean, we're talking about billions of devices, and if there's some kind of like program obsolescence for these things, I mean, what's the impact on sustainability in terms of so not just the code, but actually the resources that if we design a world where we're going to have even more waste, I mean, I think we're going in the wrong direction. So I think there's a balance to strike here, and I would hate to work for an organization that is going to produce more waste, basically. So I think it's a very important thing that we need to take into account. And
definitely. So I didn't come up with the idea to give IoT products a sort of time to live. But those are some of the discussions that you see, for example, in a recently published FTC report on Internet of Things, and it's obviously something inspired by Microsoft discontinuing Windows XP, and that has also raised questions because you find us on point of sales terminals and so on. So it's an interesting thing, an interesting question to think about, and also the approach that this company with the little printer did on open sourcing their software, which of course may not be a solution for everyone, but it's probably hard to make recommendations to companies already up front to tell them, think about what happened if your company goes bankrupt. It's a tricky problem. I don't know how to answer that.
Okay, thanks. Okay, and we're also going to have to freeze the microphone queues right now. So whoever's the last now, that's it. Okay, so I'm going to go right. Christian, it's your turn.
Okay, thank you. I'm Christian Wiedema from Microsoft. I have a question for Hannes. I mean, I appreciate that you have a privacy slide in your presentation, but I found it a tiny bit sketchy. And when I see that, yes, you point a real question, which is if we collect all that data ends up in databases that can be used for good and evil, and we have to control that, that's sure. But think of me walking around with my smartwatch and my smart shoes and my smart belt, taking all kinds of measurements and sending all kinds of radio message. I look like a green beacon that's going to turn yellow and red, and people can track me. That's a real problem. If we don't find these kind of issues of can you be tracked with those devices when they are moving? Can they listen to the traffic of those devices and deduce who's there? I mean, there are all kinds of issues there that we are just backfitting into the current TCP/IP architecture, and we should think of that from the start with the smart objects.
Definitely, and I wish I had more time to expand the privacy discussion. As you know, it's a very complicated topic with many facets, and
which is part of.
Yeah. So I don't know how to satisfactorily answer your question, other than telling you that you are right. There are complicated questions.
It's a job of the PrivSec program that we have that Christian is a member of, and we look forward to his contributions.
Okay. But thank you.
But obviously the IETF can't make deployment decisions. So, for example, in terms of if you think about one of the models that Dave described, where devices talk to the cloud, they're obviously more privacy invasive than some others who are very local, but they also provide different features. So it will be difficult to help there. What the IETF could, however, do is to develop technologies that companies could use to enhance the privacy of the end users, of the customers, if they wish to do so.
Okay, so we're going to move over to the left-hand queue here. Yes.
René Struik. I just had a few things that came up on mostly security issues. So I think one of the main impacts is really on the life cycle. I think if you look at the development of these devices, you will have lots of different elements in the chain. And it may be that components change from one manufacturer to the next. They may not trust each other. At some moment, questions come up with how, when, and where are you doing initial keying, when, where, and also are you going to put an identifier on the device, and when are you going to do binding? I think some of these issues are not traditionally well addressed in IETF, so I think that would be a good one. I was happy to see the cost of ownership slide, but I also do know that lots of cost issues come up in technical discussions, where sometimes the tendency is to water down the required functionality to meet a cost figure. And just as context, if you deploy an Internet of Things device, and as soon as you have to have a human in the loop, you've already spent more than the cost of the device itself. So I think some of these considerations should really also be tackled more by IETF itself. I still have a little bit of light. The other one is, I really like your slide about no trusted platform and physical attacks and so on. I think it's underappreciated that lots of these devices will be out in the open on a garage door, accessible to everybody. So physical attacks, implementation attacks, maybe we can replace some of the trusted platform by the network providing that as an alternative. So I think that would be a nice research topic to basically move functionality towards that. Okay.
Thank you. Bernard of Open Microsoft. So thank you for putting together a presentation with a truly terrifying series of attacks. So I have a question. One of the reasons why things improve is Moore's Law may allow you to do more of the things that you would do like in a PC or a large environment. Can you comment on how much you think Moore's Law will be a benefit here, or how much it can be exploited? Because I know there are very severe energy constraints. Do you think that, say, 10 years from now, most of the things on your slides will be fixed?
So if I find Carsten, he would probably say the benefit of Moore's Law will be eaten up by other aspects like energy efficiency and so on. But of course we see sort of interesting economics at play here, because simply large volumes of devices create new possibilities, and large volumes in sectors that actually have nothing to do with another sector actually may spill over. And so we see a lot of companies providing chips that they take from mobile phones where the volumes are massive and then apply them to completely different sectors, and you suddenly get devices at a ridiculously cheap price, and that enables new possibilities. So
I'll just add that Moore's Law helps attackers too. So a number of the attacks will still be there.
Yep.
Hi, Phil Horn-Baker. So this morning at about 10 o'clock, my iPhone went off telling me that the smoke detector in my home one of them had failed. A couple of hours ago, I got a phone call from the folk back there talking about the interactions with the fire department, because apparently the device detected that its sensor had failed and then proceeded to sound the alarm. And of course, even though this is a one-directional thing, it'll tell me that the alarm is off, but it won't allow me to turn it off because users are stupid. But that's not what I really came up for, which is My problem is the openness and the stupidity of the business models. In that I've got about 20 light switches that are internet connected, and they come from different vendors because you can't get one that meets all of the needs I have. And the thing is that every one of those vendors has the model of the customer's going to come to us, buy a box from us, and then rent the service back from us. It's kind of like capital cost and razor and blades. And it's kind of like, so I bought this Revolve hub. Okay, so which was said that I could connect up to all of them and then control them from one platform, which was fine. Only I could only control it from the iPhone, and then that was bought out by a company that bought them out and then shut them down the next day. So what this is coming to, I really need some way of knowing if a device is going to be open or treacherous. I would really like to have one IETF protocol that I could look for on the box and see if it supports that protocol. I know that it's something that I'm going to be able to control and put under my system's control, rather than being hijacked by a razor and blades model and whatever. I'd really like to see that.
So that's a good point, yes. One of the points that I made is yes, but that's not sufficient, meaning that's necessary but not sufficient, because the schema issues are still there lurking, and even if you solve the common protocol thing on the box, it doesn't mean that you don't have a proprietary schema that's in there that you can actually use. So everything that you said, and the problem is even worse.
Carrie Lynn, Verizon. So a couple comments on us. First, it might be good to socialize in a talk like this the vernacular in 7228 so that people have a common understanding of what we mean by constrained devices or the classes of those. Second, I absolutely agree with your comment that we need to do a secure update, because if we get that wrong, everything else is hosed. I like the fact that you called out, for example, that randomness, a good source of randomness, is something that needs to be built into the hardware. And I would sort of encourage you and others to work on extending that into a min cover set of what potentially needs to go into IoT devices. And I imagine that's going to be a moving target. But and finally, I rage against the dying of the light.
Michael.
Michael Richardson.
No, okay.
Does it work? Hi, Michael Richardson. So there's a bunch of things. Thanks to a great tech plenary. So the bunch of things I wanted to comment. I was aghast when I think it was actually Dan Greer that said about the stuff that IoT devices need to be upgradable or have an end of life on them. And as Carrie just said, and I was going to say, one of the things we could do and we need to do is we actually need a common secure update protocol. And, I don't know, it might be TFTP over DTLS, okay? But the point is it has to be absolutely so stupid and small that devices can run it even though they don't have the ROM to double buffer, okay? And I think that's a major contribution that we could do. The other thing that I finally took home from Dan Greer's talk and other people saying this is that it's the software that has to have an end of life, okay? The device doesn't have to go to a landfill at that point. If it's not field upgradable, it might be store upgradable. You pointed to all the JTAG programmers. So maybe some of the devices, after 5 years they stop working, or they say they're going to stop working, like my smoke detectors. I'm supposed to change the batteries twice a year, right? Or they complain to me. So maybe that's what they're going to do. They're going to say, please change me now, please change me now. I'm going to stop in 6 months. I'm going to talk to you or whatever. And you bring them in, and that's what they do. And that's how we can avoid the terrible, I think, e-waste story of that. And so again, secure update, I think we got to do it.
Yep. Thanks, Mike. A number of people have said that this week, including at the proposed research group that happened this last weekend. So yep, definitely.
Elliot.
Elliot Lear. To Michael Richardson's point about stupid small update protocols, I'm very confident we can get at least half that done. I was going to say that I just want to thank Hannes and Dave for this presentation. There are a couple of things that I think are worthy of highlight from the combination of the two presentations. The first is that Hannes put up this requirement, and we've heard a couple of people like Perry and others talk about the need for random numbers, good random number generators. But the fact is that economics works against that in terms of cost of goods and services. Now, if we couple that with the point that Dave made earlier in his presentation about RFC 1958, I think it is, that talks about the end-to-end model, what that brings us to is that, in fact, we have a very big challenge in this organization in terms of our own operating assumptions that we need to consider and decide whether we revisit the assumptions or if we double down in terms of saying, no, really smart devices need to have these things, and if so, how are they going to get them in an economically sensible way? Thank you.
Okay, thanks, Elliot.
Matt Mathis. There's also a mechanism to force retirement. And I'm going to start out by pointing out that there's been some recent stories of attacks delivered from home routers, and no way to remove these devices from the market, no way to remove them from the field. And it coming up in a security conference that it's in fact illegal to scan even to fingerprint devices to discover that they've been owned. But in fact, these devices are remotely brickable, and once something reached a threshold of an egregious bug, they should just be bricked.
Okay.
Yeah. It should be obligatory for the research community to brick them.
Okay, well, thank you, everyone, for your attention and your questions and comments.
So I'd like Brian and Andrew to come on up. So what we're going to have is a very brief workshop report, followed by a discussion of the internationalization statement that the IAB made, and then we'll have open mic. So questions, if you have about either of these two presentations, will be taken during the open mic.
Hi, so I'm Brian Trammell. This is actually the first time I've ever stood up here and said anything other than Brian Trammell, IAB. So, Brian Trammell, IAB. Also co-chair of the semi-workshop, which I'll talk about briefly, very briefly. So this was put together by the IAB Stack Evolution Program, which is currently focusing on two broad areas. The evolution of interfaces to transport network layer services beyond just sort of SOC stream and SOC DGRAM, trying to support, the new applications that are coming out of the entire community, as well as improving path transparency in the presence of firewalls and middleboxes. By path transparency, we mean, if we put a packet on the wire, how mangled is it going to come out the other side? So this is sort of following a longer interest the IAB has in general issues of protocol evolution. So I'd point everybody to RFC 5218, what makes a successful protocol. If you haven't already read it, go through it instead of the rest of this talk. It's more interesting. And the ITAT, the Internet Technology, I forget the last two words, Elliot, screen. Adoption and Transition Workshop. So within the program, we also said, well, ITAT was actually, very good in sort of framing that discussion. Let's convene another workshop in January to discuss ossification, specifically at the transport layer, and how we can fix it for emerging applications. So why now? This sort of ossification has been going on for at least as long as I've been using the internet. What makes us think that there's something that we can do at this point in time? Well, there's a lot of new energy in the IETF. So there's work that requires flexibility that we don't appear to have. So RTC Web and TCP Inc. Are looking at using the transport stack in ways so that the RTC Web data channel, which is SCTP over DTLS over UDP, we're stacking things on top of that looks like, ooh, okay, well maybe we need to think about the architecture of what's going on here. There's also work to provide that flexibility at the interface, such as in the TAPS working group. And I'm not going to say the word that we said a lot the last time, but there's a lot of them. There's also pressure created by the increasing deployment of encryption. If we do everything over TLS, which is the easiest way to do it, then we're going to brick a lot of deployed middle boxes. Okay, and we can go home now. That's not a problem. But there is an opportunity to strike a balance between breaking everything and having no privacy, and we wanted to look at how we can sort of do this, how we can get the look off of Woody the operator's face and maybe make this a little bit less painful transition. So, quick summary of the workshop. We had 20 position papers accepted. We sent 38 invitations. The stated goals of the participants at the beginning of the workshop were we want to get a deeper understanding of the architecture and the incentives to deploy changes to the transport stack. We want to look at what we can do to broaden these interfaces beyond BSD sockets. We want to look at the state of further research and community education, but a lot of people, above all, there was a lot of interest in definition of these cooperation approaches for Middleboxes. There were kind of two camps on transport evolution, and I know at least one of you is going to get up the mic and correct me about this, but it's a pretty good joke. There was the People's Front of UDP and the TCP Liberation Front. More seriously, there is a balance between how much energy do we want to put into fixing the fact that there's a lot of Middleboxes out there. Oh crap, I said it. A lot of devices on path which believe that they're helping by mucking about in TCP packets, and how much do we want to say, let's put a new header on it so that you don't know what's going on. So the identified goals of the workshop were some future work. We didn't know whether it's a working group, a research group, a mailing list, a barb-off, a bunch of people in a bar, talking about mechanisms for detection of these things on the path and for impairment detection and troubleshooting, and look at the characteristics. Better understanding so architecturally of how transport should and must evolve, including applicability of specific transports to specific use cases. Exposing more information to the application about transport in the right way so that it's actually useful, not just giving more knobs that are never going to be used. And then identifying the trust issues and employment incentives and cooperation evolution approaches. So it turns out that if you're actually letting devices on the path do things to your packets, this works really, really well if you've solved the trust and key distribution problem, but otherwise it's hard. One of the easiest outcomes to come to was the outcome on measurement. We didn't talk about this very much because we went around the room once and said, yeah, we know what to do, let's actually do it. The result was the hops barb-off at 9:30 Sunday night last night. I got to say, the hotel was very nice in letting us take beer en masse from the bar to one of the meeting rooms. It was an actual barb-off in a hotel. I was impressed by that. The idea here is that basically we're making decisions about how we're going to move forward, and we need data to do it, and we need to get the people who have the data together with the people who have the questions that they want to ask of that data. On cooperation, this is a slightly revised version of the slide that I didn't get to present last time in Honolulu. Thank you, Dave. Joe. And the idea here is that you have an architecture for exposing what you must to the path. Everything else is end-to-end up in this green box, and crypto keeps everybody honest. So we're going to be talking about that at the Spud-Boff 9 a.m. Wednesday in this room, actually, it turns out. So we do have enough space, apparently. So once you have this mechanism, okay, here's the thank you, Dave. Once you have this mechanism, what do you say with it? The things that came out of this discussion is that there needs to be an incentive to expose information both for the applications, the endpoints, and the path. And there need to be incentives not to lie. So we've done a lot of approaches at path signaling before, and if you get something by lying, then you're going to do it. So you need to describe or define the vocabulary in such a way that you don't get anything for lying, or at least you don't get anything predictable for lying. This is easy to look at in the app path situation. There is probably a minimal set of useful information which you can expose, which is useful to the far endpoint, which can be verified. So for example, things like session lifetime. I mean, you get this right now. Middleboxes look at the TCP flags and say, okay, well, here's the SYN, here's the SYN-ACK, and here's the FIN. If you've encrypted the TCP header, you need some way to expose, okay, this is the first packet, this is the last packet. The way forward is less clear when we're looking at the signaling in the other direction from devices on path back to the applications. This might be a tractable problem. It basically looks a lot like ICMP, but in band and bound to a socket so that it's easier for the kernel to figure out where to take that ICMP message and hand it off to the application. So if it's treated in that way, then it might be a tractable problem. But if the path is saying, here is something, you must do it, this goes into the trust issues, and this is previously unsolved and very hard. So things to do, I really hope to be able to point you at a initial workshop report here, but I will point you at the webpage, IAB Org Activities Workshop Semi, where we have the transcripts, the slides, and the position papers up. The initial workshop report is real soon now, and I'm going to say mid-April in order to force myself to get it done. There's been some cooperation with the ETSI forum on Middlebox issues, especially with respect to encryption. There have been, we'll have discussions on transport extensibility in area meetings in the Prague timeframe. There's some work on encapsulation guidelines for UDP, and expect at some point a statement coming out of the program in the IAB on architectural assumptions in transport evolution. So, if you'd like to learn more on the SPUD thing, on the cooperation protocol, come to the BOF again Wednesday morning here in this room. HOPS has already happened, but you can join the mailing list. That's hops.ietf.org. The Transport Services Working Group is working a little bit on the interfaces and sort of the services that are, well, Transport Services is working on services provided by transports, like looking at how you can decompose transport protocols in ways that you could build interfaces on top of this that would be more adaptive. And then other future work can be referred to the Stack Evolution program. Thank you very much.
Yes. We already do. I don't know what's up there. I don't know what to do, Cindy. Exactly. Do you know what to do? Yeah, that little. I did that.
This is, I think, beautiful. All right. Well, what I'll do is talk. All right. How about this?
So that's all I know. Peter.
Oh, they have to turn it on back there, so I'm going to give this a try. How's that? Oh, there we go. All right. So while we fool with the display issue, because this is sort of ironic, right? We had you may be aware that there are people in the world who do not write in ASCII characters, and they sometimes like to have identifiers that are useful to them in things that they write in, because that way they can remember them, because they can't remember things in ASCII characters because they don't use them. So the idea was that we were going to internationalize identifiers, and so what we did is we picked Unicode, and you may all remember that there have been a number of plenary topics about this and all the rest of it. Right. So we had a mechanism for this called IDNA 2003 for the DNS, and we didn't like that, so then we came up with IDNA 2008, and that seemed to be working fine, and so then we generalized that entire approach using a thing called Précis, and that working group is in the final stages of what its work. And this all depends on a thing called Unicode, which is a way of having a universal character set, right? So there's the background. Now, Unicode has versions, and each version of Unicode adds some characters, adds some code points, because code points are what makes up Unicode. And in the version 7, there were some characters that were added, some code points, and this gets added to the IDNA 2008 stuff. Look at that. Using expert review. So we had an expert review, and the expert review noticed a thing. And the thing that it noticed is that there is this history. Still not working for you.
It's not putting what I want up there.
How about if you gather the windows? I don't know.
That's my next try.
I'm apparently not in IT anymore. So the idea was that we would look through this. So Unicode 7 added a code point called be with Hamza above, which is an Arabic code point. Now, it turned out that we always had this ability to write the character be, the Arabic character be, and to put a mark called Hamza above on it. And it produced a thing that looked a certain way on the screen, which in the event we ever got this working, you would be able to see. And the new, this is the answer. We just call the manufacturer. I think this is what we need. This is what makes the IETF great. Look at that. Thank you very much. Thank you. Here, I'll give you that back. So thank you very much to Stuart. So what happened is we've got this be with Hamza above character, and we had the previous arrangement, which was the be with the Hamza above. So this is how we realized it. And the IAB put out a statement because we were worried. Identifiers are used by humans, and these were in the single script, and we had a bunch of meta rules for how you would do these kinds of things. And the thing is, it didn't seem to us that humans could tell these apart, but of course, they're different code points, and so machines are going to think they're different. Humans don't tell them apart. That seems like a problem for identifiers, right? Because if you have two things that you think are the same, but the machine thinks are different, not a good identifier. It turns out this is not abnormal. This case that we discovered, or we stumbled upon for the first time, there were some other cases in Arabic script that we noticed, and those were originally included in the IAB statement. That was unfortunate, and we updated it because, in fact, this is not related to Arabic at all. And it turns out there's a whole bunch of cases like this, and it's not even clear that they all work the same way. So the IAB called for some work. We said, would you please have another look at this, because identifiers are sort of an important thing, because you want to identify things because that's what you wanted to do in the first place. So we said, well, would people please do some work? And fortunately for us, some people got together and decided, well, yeah, we ought to do that. And so we've got this Lucid BOF on Wednesday. It's in the Parisian room, which is itself kind of ironic because it's misspelled, right? But it's in the Parisian room on Wednesday afternoon after the lunchtime session. There also is a talk to working group chairs on Wednesday about Précis and how that might affect your working group. So we're hoping that that this is going to work, and that this time for sure we're going to get it right. That's all I have to say about this topic, and with that, I'm going to call the IAB outgoing and incoming up here, and apparently I get to stand up and be the main tomato target. And I guess I can probably turn this off, because having an IAB thing with, turns out it's not abnormal at the top. And we are going to open the mics now, so if you've been holding up your remarks, now is your chance. Is there a way, in fact, to just... Very nice. This is a mallet, right?
Yeah, but you don't have the reach.
It's good. All right, I'm going to start. I'm going to start all the way over there because you haven't sat down yet.
Ralph Drums, incoming. Marc Blanchet, IAB. Saturday IAB.
Suzanne Wolf, incoming IAB.
Elliot Lear, outgoing IAB.
Joel Halpern, outgoing IAB.
Eric Nordmark, IAB.
Brian Trammell, IAB.
Andrew Sullivan, IAB. I guess I'm the chair now.
Russ Housley, outgoing IAB Chair.
Mary Barnes, IAB.
Robert Sparks, incoming IAB.
Dave Thaler, continuing.
Sue Lee, outgoing IAB.
Yariak, IETF Chair.
Joe Hildebrand, continuing.
Heather Flanagan, RSC editor, not actually IAB.
All right, we'll start here.
David Black. Andrew, following up on the presentation you just gave, wanted to ask, did you want to say anything about Unicode normalization forms and how they've saved us from this mess in the past, or is the right answer to my question that rat hole belongs in LucidBoff?
That question does belong in the LucidBoff, and part of the issue is that we thought in the past that normalization forms were in fact solving this problem. The problem in this case is that the be with the hamza above, like the combining sequence, and the precomposed character are, from Unicode's point of view, totally different characters, and therefore they don't normalize to one another. That's the short version. Come on Wednesday for the long version.
Bingo. That's exactly what I wanted you to say. Thank you.
Let's alternate. No, I guess we can't alternate. Try again.
Needs the IoT.
There we go.
Yeah. Carrie Lynn, Verizon. And I guess my question was similar, and the answers probably show up at the BOF. You mentioned that there are, many of these cases of composable characters. What's the definition of many? Do you have some rough approximation?
Well, we know that we've got definitely on the order of tens that we have. Oh, sorry. The question was, I said that there are several of these cases, or Carrie rather said there are several of these cases. How many is several? We're pretty sure it's not hundreds, and we're pretty sure it's tens. But the truth is we don't exactly know because there are really a lot of Unicode characters, and we don't want to go through them one at a time. Right. That was the whole goal, not go through them all one at a time.
I guess one question I have is whether it's possible to do something like a Martians list or something. That's
excellent question, and I think that Wednesday is your day.
Hi, Michael Richardson. I wanted to ask or comment about the semi work, and it has been maybe 15 years that the IPsec working groups have received various could you please expose this because I could do nice things for you if only you would let me mess with your packets, and it came back over and over and over again, this kind of conversation. And I can remember a conversation with one very spirited telecommunications 3G guy in Vienna, and I kept saying to him, what's in it for me? Right? I'll be happy to tell you anything you like, but what's in it for me? The end point, right? And what I discovered was that either he didn't know, or he wasn't willing to tell me, or his agenda was not what he was stating it was. And so I guess one of my questions going forward, and I don't know if there's some negotiation that's going to be happening with the Middlebox community, I guess I can call it that. But I guess I kind of wonder, is there going to be some kind of standard questionnaire that they're going to be said, like essentially, what's in it for me?
Yes.
Or us? IETF? Yes. Okay. Yes. Thank you. That makes me
come to the BOF and help us with that. I mean, we have that on the. I mean, that's one of the like slide number 6 at the BOF.
Awesome. Thank you.
So come and help us make that list of questions.
Yeah, I'll be one of the co-chairs for that, Bob Michael. And one of the things that, before we even start, any sort of arrow throwing about this, by having the usual naysaying of that happens, the first question that has to be asked is, what is the value of the new service that the existing services don't bring? So that has to be answered I think, as this technology matures. Whether it gets answered Wednesday or not, I don't know, but hopefully it'll be a good start to it.
That's it? Okay.
Mike Jones, Microsoft. I'm going to follow up on the Unicode thing again, and I'll ask a naive question, which I suspect other people are wondering as well. There's a lot of characters that are indistinguishable from humans. Greek uppercase A looks a lot like Roman, or uppercase alpha looks a lot like Roman uppercase A. Is it the case that this wasn't a problem before because the normalization rules fold them? Or why was this not already a problem?
So it is already a problem, and there are other kinds of such problems, and the really short version of this is Wednesday is your friend. But the slightly longer version of that is this particular case is an example where there was no property by which you could derive something else. So for instance, in the example you just gave, one of them is Greek script and the other one is Latin script. So I have something by which I could make some kind of determination. And this is a case where we don't seem to have that yet.
Thank you.
Warren Kumari.
Oh, yes, please.
Go ahead.
I just want to add that what's special about these cases is really the only thing that distinguishes them is language, which is not really a property. And so that's why the lucid BOF is the language for your locale-free Unicode identifiers. Is what happens when you don't have a locale or a language ID together with the identifier. That's when the problem comes up. And so that's the scope of the BOF.
Warren Kumari, Google. So I wasn't really following the IDNA stuff that closely, but I seem to remember the Unicode consortium telling us this wasn't going to happen. Is that wrong?
Well, I don't. Oh, so Warren Kumari said that he wasn't following the IDNA stuff too closely, but he seemed to recall that the Unicode folk, by which I think he means some people who are active in Unicode, told us that this wouldn't happen. And so there are three things that I want to say about that. The first thing is it's very, very hard to tell the true story of the past. And I'm not going to go into my personal life. But the second thing I would say is that Unicode is really hard. The case that we stumbled on is this Hamza above. That was the one that first got us into it, though it's not the only case, and I want to emphasize this is not an Arabic problem. There are several pages of densely written text in the Unicode standard about how Hamza is hard and really complicated. And you can reproduce that problem for every single other script because every script has some sort of weird corner because humans were involved in it. And when humans do things over thousands of years, they mess stuff up. So that's the final thing, that there just aren't these kinds of promises. And part of the problem, and this is the third thing that I really want to say, part of the problem is that this is a case where we're trying to work on a thing that is very, very clean because we have one purpose in mind. And Unicode has all the purposes there are that you could possibly write anything down for. Unicode has to do that. And so they're going to make compromises and trade-offs that are entirely reasonable when what you're trying to do is encode everything that's ever been done. And what we have to do is this tiny thing here, and we don't want anything to screw up, and that is not maybe the common goal that we thought it was. So maybe there was some miscommunication, I don't know, but it doesn't really matter what happened. Here we are, so let's go forward and solve it. I don't know if anybody else has something to say. Oh, Mark.
Related to this discussion we're having is the scoping of the problem, what exactly we're trying to fix, and that's probably the most challenging of the BOF for our work, is to make sure that we understand together with the Unicode people that we're fixing the same problem, because over the last couple of months we've been discussing trying to focus on the scope, and so again, come to the BOF.
Hi, Phil Baker. Yeah, on the Middlebox issue, I think I'd like to see a bit more attention paid to why people are deploying these Middleboxes beyond the standard IETF response, which is that the people deploying them are ignorant monkeys who should know better. And that is a very damaging response attitude that I get frequently. On the TLS side, don't think that TLS is going to end Middleboxes messing with stuff, because the problem of man-in-the-middle TLS certs is vastly worse than anybody who hasn't measured it knows. We track all certificates that pass through our browser. There's over 1 million man-in-the-middle certs out there. Pretty soon there will be more man-in-the-middle certs than real certs. Some of them are issued by people who actually want to break TLS because they are malicious and want to tap into conversations. But most of them are issued inside corporations for reasons that have to do with network management within the organization that they have found can only be solved with a Middlebox. And I think one of the big disconnects that happened was, back in the past, the original IETF view was the internet is a network of networks. What you do on your network is your affair. As soon as you go to the one internet that connects the network of networks together, you speak IP and you obey the internet rules. And then we had this IP to the edge thing. And what didn't get carried along was the understanding that I might be speaking IP on this device, but that device is connected to my network. It is not connected to the internet. And that's a very subtle piece of the original internet architecture that if you go back to the founding documents, which I've been doing recently for a history project, you will find is very clear. It is in the end-to-end argument. You will see that. And I think that we've got to recapture that and understand why people are doing these things, because they need to manage their networks and give them the tools to manage their networks and not bust TLS. All right. I don't really care about breaking TCP or IP. Breaking TLS, that's a big deal.
So there are a couple of things that you raised there, so let me try and take them in a couple of turns. One of them is from the SPUD perspective, and my contribution to SEMI was actually around Middleboxes and path characteristics, and the fact that we were actually moving out of an era when these things are boxes to being virtualized network functions that can pop themselves and appear in a variety of places in the path that aren't necessarily where they were. And one of the things that writing that showed me was that we have a very unique way of looking at the path inside the IETF that presumes that the path is determined by the source and destination and the actions of the routers between it. And the reality is that in the modern internet, the full 6-tuple actually determines the path you take through the internet or through the network, because the 6-tuple determines what middle boxes you need to pass through in order to pass these administrative functions that you describe. And I think that one of the things that the workshop was very clear on was we were not trying to say these things are evil. What we were trying to say is, given that we wish to have an unbroken, encrypted, and confidential channel between the two endpoints which have started TLS or similar, what's the minimum we need to expose in order to make middle boxes actually be able to function without losing privacy concern, without creating privacy concerns? So if you come to the BOF, you'll see much more about this, but the very basic thing we're looking at here is session semantics coming from the app to the path that tells something like a NAT, this is the start and stop of the session, so that you don't have to do heartbeats through the NAT to maintain that NAT binding, because it knows when the ID is gone that the session state is gone, and there's an explicit session end identifier for it to see. Similarly, we're talking about from the path back to the application, what's in essence a 6-tuple ICMP. The same kind of information we would have gotten from the path before we saw this differentiation in paths based on the 6-tuple, now actually scoped to the way the paths really work. So I don't think that SEMI or the work that's coming out of it is in any way, shape, or form saying middle boxes are stupid and we have to break them. We know that's a losing proposition.
We understand that that's just going to make TLS interception more prevalent. What we're trying to figure out, and this is what we encourage everybody to come to SUD and work with us on, is what are the session semantics that meet the characteristics that Brian laid out? They're something we can trust but verify. They're useful enough to get deployment, as Michael pointed out early, and that they're the minimal set. So we don't have to give everybody everything to get anything. So
what's the sixth tuple?
Sorry?
We can't seem to figure out what the sixth part of the sixth tuple is.
SCP marking.
Oh,
to go with the other part of the five tuple. Sorry. And the other bit that I wanted to say in terms of your concern that we are not worried enough about TLS interception, as the program lead for the PrivSec program, I can tell you we're terrified. We're happy to be more terrified if you want to explain it to us more, but what we really need to do isn't be terrified about it, it's to work our way past what's causing it. And I think that one of the things we're doing is matching efforts to increased encryption with looking at the constraints of the web PKI and what second sources of truth can be introduced, like DNS-based DANE sources of truth or other things that help us move past the point where we're trusting everyone to tell us anything. We really need to get past that, and we all know it. So once again, there's a lot of work to do. Some of it's going to be in SPUD, some of it's going to be in Utah, some of it's going to be in lots of other places. But we just need to get cracking.
A quiet bunch. And I have to say, I am astonished that the lights never really changed colors in the way that was unexpected. So I guess probably I end up paying out, right? So I see nothing more. I think we're about at the end here because there's nobody at the microphone. So thank you very much, and thank you for coming.